Hello everyone, I'll take you through a brief introduction to temperature sensors and transducers. Our learning outcomes for the lesson will be: 1. You should be able to define what is a sensor and what is a transducer. You should also be able to describe various examples of temperature sensors and transducers. So we start with definitions. What is a sensor? A sensor can be defined as a device that gives an output by detecting the changes in quantities of a variable. Hence, in our case, a temperature sensor detects changes in temperature and gives a relative output. A transducer, on the other hand, is a device that converts energy from one form to another. You can say a temperature transducer converts temperature change into a physical variable, e.g. into an electrical signal, which then can be processed further to give the value of the temperature change. What do we deduce from the definitions? We can see that sensors can also be transducers. However, in addition, a system may use transducers in addition to the sensors to convert signals from one form to another. Examples of temperature sensors and transducers. 1. We have bimetallic strip, liquid in glass thermometer, thermistors, thermocouples, thermodiodes. We'll look at each of these examples and try to describe them. Bimetallic strip. A bimetallic strip consists of two different metal strips of the same length bonded together. Because metals have different coefficients of expansion, when the temperature increases, the composite strip bends into a curved strip. As we can see here, we have the two strips together. One is of a higher coefficient of expansion, the other one is of lower. So when heated, as seen here, the higher one, the top one with the higher coefficient, expands faster, and then it bends the strip and opens this contact here. Liquid in glass thermometer. This one is very common in laboratories. It consists of a glass thermometer and a capillary tube. The head to which the liquid expands is a measure of the temperature. We can note that common medium used is maybe mercury or alcohol. Thermistors. Thermistors are semiconductor temperature sensors made from mixtures of metal oxides such as those of chromium, cobalt, iron, manganese, and nickel. The resistance of thermistors decreases or increases in a very non-linear manner with an increase in temperature. So for the one that decreases with an increase in temperature are referred to as negative temperature coefficient thermistors, the NTC thermistors, and the one that increases with the increase in temperature known as positive temperature coefficient thermistors. So that is how they look in a circuit. You can be able to point out. Thermocouples. A thermocouple involves two junctions formed by joining two different metals together. Thermocouples operate on the physical principle that when any two different metals are joined together, an EMF, which is a function of the temperature, is generated at the junction between the metals. So we have the hot junction here. This is in contact, that gets to contact with the body that you are measuring temperature, and this is our reference value. So the difference, the EMF that is generated from the change in temperature in this hot junction can be processed further to give us now the value of the temperature. Thermodiodes. Thermodiodes operate on the principle of p-n junction, whereby a voltage across the diode changes linearly according to temperature changes, i.e., as the temperature increases, diodes' forward voltage decreases. Thermodiodes are normally embedded on microprocessors to monitor their temperature, and also in temperature sensor integrated circuits like LM3911 or LM35, as shown there below. So your assignment will be to categorize the examples learned and state for each whether it is a sensor or a transducer. Research on the applications of the various temperature sensors and transducers you have learned in this session. Goodbye.